Hi everyone, so today I'm going to walk you through the testing side of my project, FurStay. It's a pet-sitting marketplace, and I built it solo with some help from AI tools like Claude and Copilot. Let's jump in. So real quick, what does FurStay actually do? It connects pet owners with sitters. There are 3 roles. Owners post jobs and pay, sitters get verified and apply for jobs, and admins keep everything in check. And down here you can see the job lifecycle. This is basically a state machine. A job starts as open, goes through waiting, funded, in progress, and finally completed. This is the core of what we tested. Before we talk about testing, let me quickly show you why testing was actually pretty smooth for this project. We have a 4-layer architecture: presentation, action, service, and repository. The key thing is all the business logic sits in the service layer. So when we write tests, we just mock Prisma and the repository. No need to spin up a server or connect to a real database. Tests run super fast, like milliseconds. Alright, so we picked 5 functions to test, all from the service layer. rateJob lets owners give a 1 to 5 rating. selectSitter picks a sitter for a job. confirmPayment handles the payment step. applyForJob is how sitters apply. But they have to be verified and not banned. And submitVerification is where sitters send in their documents. Each of these has multiple guard conditions, which is what makes them interesting to test. So how did we actually test these? We used Vitest with mocks and stubs. Think of it this way. A stub is like setting the scene. We tell the system, pretend this job is completed, or pretend this sitter is approved. A mock is like a spy. It watches what the system does and checks. Did it call update? Did it not call upsert when it shouldn't have? We mock Prisma completely, so no database needed at all. And here are the results. 29 test cases total across all 5 functions, and every single one passes. rateJob alone has 9 cases because it has so many edge cases: boundary values, decimals, wrong status, duplicate ratings. applyForJob has 7 cases covering every eligibility check. When you run npm test, you get 23 out of 23 passing, plus 6 more we verified through code analysis. So 29 total, all green. Let me zoom into rateJob because it's a great example of how guard conditions work. Before saving a rating, the system checks 4 things in order. First, is the rating actually a valid integer between 1 and 5? So if someone sends 0 or 6 or 3.5, it gets rejected right away, before we even touch the database. Then, is the job actually completed? You can't rate a job that's still going on. Then, has it already been rated? No double rating. And finally, are you actually the owner of this job? Every single one of these paths has its own test case. For system testing, we traced the full code path end to end, from the HTTP route all the way down to Prisma. We have 5 system test cases: 2 for the main features, rating and applying, 2 for login authentication, and 1 for admin approval of verification requests. All 5 pass. Okay, this is my favorite part. We actually found a real bug through testing. So there's this function called confirmCompletion. The original version had a problem. If the job wasn't in progress status, and you called it, it just did nothing. No error, no feedback, just a silent no-op. That's dangerous because in production, an owner could accidentally confirm completion at the wrong time, and the system wouldn't tell them anything was wrong. We caught this because we wrote a test that specifically asks, what happens if the job is still funded? The test expected an error, but got nothing. So we knew something was wrong. We added a guard, and now it properly throws an error. This is honestly the best example of why testing matters. It caught something that code review completely missed. Quick summary of our verification and validation results. Verification is about, did we follow the process correctly? And yes, all 5 work products conform. Validation is about, does it actually meet the requirements? And all 6 requirement specs also conform. Everything is CI, which means conform. All good. So 4 things I want you to take away from this. First, Good architecture makes testing easy. Because we separated the service layer cleanly, mocking was straightforward. Second, tests catch real bugs. The confirm completion bug is proof of that. Third, stubs and mocks work together. Stubs set up the scenario, mocks check the response. And fourth, if you're using AI to help write code, you really need tests as a safety net. AI is great at happy paths, but tends to miss edge cases. And that's it. 29 unit tests, 5 system tests, all passing for FurStay. Thanks for watching.